Good morning, students. Good morning, all of you. Today we will discuss about flexible and rigid pavements. That means types of pavements. Pavement is nothing but a road. Okay. So what are the types of pavements and what are the failures of those pavements? What is the comparison between those flexible and rigid pavements? We will see now. Okay. So basically, definition first we have to know what is pavement. Pavement is nothing but it is a structure which consists of multiple layers. On that, the wheel load will come, wheel loads will come. So that wheel load will be distributed through different layers of pavement, and the load will finally reach to the subgrade. Subgrade means it is the bottommost layer of the pavement. So on the subgrade, subbase will be there, base course will be there, and the topmost course is wearing course. So these are the layers in the pavement. Okay. So there are two types of pavement: flexible pavement and rigid pavement. Flexible pavement means which is consisting of flexible material like bitumen, tar, etc. Okay, so the example of flexible pavement is bituminous rock. And the second one is rigid pavement. Rigid pavement means which is a strong pavement. That means which is consisting of cement concrete material. So cement concrete pavement is called comes under rigid pavement. Okay, so these are the basic types of pavements. Two types of pavements. So flexible pavements. Flexible pavements means these are negligible flexural strength. There will be low flexural strength, and they are flexible in their structural action under load. So if wheel load comes on this pavement, their action will structural action will be flexible. Okay. So load transfer. How the load transfer will be in the flexible pavement? Let us see. Load is transferred to the lower layer by grain to grain distribution. See here, this is wheel load, this is wheel load, and this is pavement. So this wheel load will be distributed to the underlying pavement layers to grain distribution is there. So as shown in the figure, the wheel load will be distributed to the different layers of pavement through the granular structure by grain to grain distribution will be possible in this flexible pavement. Okay, so this wheel load acting on the pavement will be distributed to the wider area. See here, a truncated cone will be formed. It is a frustum of a truncated cone. So a wider area, the load will be distributed through the different layers of the pavement. Let us see what are the layers. Surface layer, that means wearing course. Next course is base course. Next course is sub-base course. And final course is subgrade. Subgrade means nothing but a natural soil. Okay. So the stress decreases with the depth. So the stress which is coming through the layers will be decreased with the wider area of the when compared to the depth. So flexible pavement layers reflect the deformation of the lower layers onto the surface layer, right? So this is about mechanism of the flexible pavement, load distribution mechanism. Next, what are the different layers in a flexible pavement? Already I have told you. First one is natural subgrade, that is natural soil. After that, compacted subgrade, 150 to 300 mm thickness will be provided. On that, subbase course, 100 to 300 mm thickness of subbase course will be provided. On that, base course 100 to 300 mm. Next, binder course like DBM, etc. And on the binder course, surface course 25 to 50 mm will be provided. That is nothing but wearing course, top course. Okay. So these are the different layers of the flexible conventional pavement. Okay. So if the layers of conventional flexible pavement includes seal coat, surface coats, pack coat, binder coats, prime coat, base coat, sub-base coats, compacted subgrade, and a natural subgrade. That means on natural subgrade, we will compact with roller. That is called a compacted subgrade. See, let us see one by one definitions of each layer. Surface course is the topmost layer. Okay, it is the layer directly in contact with the traffic loads. That means the traffic load, wheel load will be directly contact with the bearing course. And these are constructed with dense graded asphalt concrete. Okay, so the top course will be constructed with the dense graded asphalt concrete and the bituminous concrete. Next, binder course. What is the purpose of binder course is to distribute load to the base course. That means the load which is coming from surface course will be taken by binder course and it will distribute to the bottom layer that is base course. Okay. So binder course requires lesser quality of mix as compared to the course above it. So in this lesser quality of mix compared to this surface course will be provided. Next, base course. Base course means the course which is below the binder course. Okay. It provides additional load distribution and contributes to the subsurface drainage. So base course is provided for meant for drainage of subsurface layer. Whatever the water in the subsurface, it will be drained off from the base course. Okay. So the base course, the load will be taken from binder course and it will be distributed to the from base course to the underlying layers. Below the base course, a course will be there, that is sub-base course. So the primary function of sub-base course is it gives structural support, it improves drainage, and it reduces the inclusion of fines from subgrade in the pavement structure. And that means sub-base course is a layer which arrests the entry of fines from subgrade to the into the above the layers of the subgrade, that is pavement structure. So it arrests, it prevents to entering the fines into the subgrade, from the subgrade into the pavement structure. That is the purpose of subbase. Okay, next, subgrade. Subgrade means nothing but it is a natural soil. How much depth we don't know. It is unlimited depth. Okay. So subgrade is the topsoil. It is a layer of natural soil prepared to receive the stresses from the above layers. What are the above layers? Subbase, base course, wearing course, etc. So all loads will be distributed from wheel load to the underlying loads by grain to grain analysis, grain to grain distribution. Grain to grain distribution is possible in the flexible pavement. Okay. Next, what are the failures of flexible pavement? We will see. There are 10 types of failures are there in the flexible pavement. First one is alligator cracking, which is also called as map cracking. That is fatigue. Fatigue. Okay. Second one is consolidation of pavement layers. That is rutting. Rutting means potholes. Those are called rutting. Next, shear failure cracking, longitudinal cracking, and the lengthwise cracking. Frost heaving, lack of binding to the lower course. That means there is no proper connectivity between two consecutive layers. That is called lack of binding to the lower course. Next, reflection cracking. Next, formation of waves and corrugation. Bleeding. Bleeding means in summer you can see the bitumen will be heated by the sun heat, and it will be it will come onto the pavement like liquid. That is called bleeding. Pumping. Pumping means let's see what are these failures by with the pictorial representation. So this is called fatigue cracking, alligator cracking or map cracking. See, this is the alligator cracking or map cracking. Like what our maps, India map, like that maps are there now. So like this, it will be developed. Okay, what are the causes for this failure? Hmm? Let us know what are the causes of this failure. Relative movement of pavement layer material. Hmm? That means pavement layer materials in that relative movement is a cause for this type of failure. Next, heavy wheel loads, repeated application. That means heavy wheel loads due to these heavy loads repeatedly applying on this pavement will cause this type of failure. Next, swelling or shrinkage of subgrade or other layers due to moisture variation. So there will be moisture variation depending upon seasons. So there will be shrinkage of subgrade or other layers or swelling of subgrade or other layers. Due to this type of alligator cracking or mat cracking or fatigue cracking will be formed. See here, rutting. Rutting means the depression. See how much depth it is by if you put a ruler or a scale and if you measure this one, that is called rut. Okay, depth another. This depth is called rut. Okay, due to repeated wheel loads. See here, formation of rut falls in this type of failure. A rut is a depression. See, this is a depression. So this is known as rut or groove into a road by the travel of wheels. So continuous wheel loads on the same path will create this type of failure. This is called rutting. Okay, this type of failure is caused due to the following reasons. Repeated application of load along the same wheel path resulting the longitudinal cracks. This is called a longitudinal crack. So a vehicle was traveled in this direction in this path. Next, same vehicle, next different vehicles will, if travels in the same path, due to that wheel loads, continuous repeated wheel loads, this type of effect will be formed. Longitudinal ruts will be formed. Okay, longitudinal depressions will be formed. So these are called rutting. Okay. Next one. Wearing of the surface coats along the wheel path resulting shallow depths. Okay. So this top layer will get rutted due to the continuous movement of heavy vehicle wheel loads in the same path. So that this type of rutting failure will be occurred. Next, shear failure cracking. See here, a crack will be formed on the road. This is called shear cracking. Okay, shear failure causes upheaval moment of pavement material by forming a fracture or crack. Okay, what are the causes? Excessive wheel loading. So, if the load is more than designed, it will weak. The top layer gets weakened. So, crack will be formed. Low shearing resistance of pavement mixture. So if there is proper mix is not achieved while laying this top layer, so due to improper mixing, okay, so shear resistance will be less, so that the failure will be occurred. Crack will be occurred on the top surface of the pavement due to improper mixing of material. So this is called shear cracking. Longitudinal cracking, if you observe this one on the road in longitudinal direction, a crack will be found in a longitudinal direction. So this is called longitudinal cracking. So this type of cracks extends to the full thickness of the pavement. See, this crack will be developed to the bottom of this layer, not only on the top of the pavement, it will extend to the through thickness wise to the entire depth of the first layer, top layer. Okay. What are the causes? Differential volume changes in subgrade soil. So subgrade is the bottommost layer. If there is any volume changes in this subgrade soil, the crack will be formed. అలాగే settlement of fill materials. So road is consisting of different layers. First of all, if you fill, if there is a low-lying area, we have to fill that area to make a level road. So if there is any settlement of the due to the filled material in the different layers, I mean the subgrade layer. So that settlement also occurs this cracks, causes this cracks. Okay, sliding of side slopes. See, adjacent to carriageway there will be embankment slopes. Are you able to see here? So these are the embankment slopes. So if the side slopes are made with 1.5:1 or 1:1 depending upon the height of the embankment. So if the side slopes are slided, then also this possibility of longitudinal cracking will be occurred. Next, frost heaving. See here, this type of distress, this type of failure is called frost heaving. Frost heaving causes upheaval of localized portion of a pavement. The extent of frost heaving depends on the groundwater table and climatic condition. See, climatic it depends. This type of distress is caused only due to localized only. It will not. It is a localized failure, and due to the difference in water table, groundwater table, and next climatic condition, this type of distress will be occurred. Next, see here, these are potholes. Potholes. You can see anywhere in our roads. This is depression. This Distress is called pothole. Okay. Lack of binding with the lower layer, potholes and slippage. This is a sixth one. Sixth failure, sixth distress. When there is lack of binding between surface coats and underlying layer, some portion of surface coats loses of materials, creating patches and potholes. So, if there is no proper binding between top coats and below underneath layers, some portion of surface will create some holes. Those are known as potholes. Slippage cracking is one form of this type of failure. Slippage cracking is one form of this type of failure. Okay. Lack of prime coat or tack coat in between two layers is the main reason behind this type of failure. So on this wearing coats, we will have prime coat and tack coat. If there is in between these prime coat and tack coat, if there is no connectivity, no bonding between these two coats, that is the main reason to cause this type of failure. Reflection cracking. Reflection cracking. This is called reflection cracking. This is called reflection cracking. So this type of failure occurs when bituminous surface course is laid over the existing cement concrete pavement with some cracks. This crack is reflected in the same pattern on bituminous surface. So this failure, whenever your overlaying technique is used, that means on existing cement concrete pavement, if you place bituminous BC road, BT road, then this type of cracks will be formed. This is called reflection cracking. That is called method of overlaying. Overlaying means there are different types of overlays are there. Bituminous concrete on same bituminous road, or bituminous road on tar road, sorry, cement road, or cement road on existing cement road. Like that, four possibilities are there in overlaying techniques. So this is the type of failure which will be happened in this different layers of different materials of pavement are formed. That means when bituminous surface is laid over the existing cement concrete pavement, this type of reflection cracking distress will be formed. Okay, అంటే existing cement concrete road మీద మళ్ళీ once again if you provide bituminous concrete layer, then that type of reflection cracking will be formed. Now coming to eighth distress, formation of waves and corrugation. See here, do you know this? What is this? Ah, yes, ranging rod. So, if this ranging rod is put on the top surface of the pavement, you will notice some depressions in this pavement layer, top layer. So, these are called the formation of waves. Are you able to see? So, these are the different, this is in the form of wave. This is in the form of wave. Wave means up and downs. Okay. So, like that, the waves will be formed. Transverse undulation appear at regular intervals due to the unstable surface force caused by stop and go traffic. See, on the road due to congestion of the traffic, the vehicles will be stop and move, stop and move, stop and move. So with this type of wave formation will be occurred on the top layer of the pavement, top surface of the pavement. See here, bleeding. I already explained in the first slide, not the first slide, failure slide. I already told you 10 types of failures are there. In that slide, I explained what about bleeding. So excess bituminous binder occurring on the pavement surface causes bleeding. Excess bitumen it will be appeared on the top surface of pavement. Bleeding causes a shiny, gloss-like reflective surface that may be tacky to the touch. So it will be formed like it will create shining. It will create shining. It will be of like a glass. It will reflective surface will be occurred. So if you touch, it will be sticky. So usually found in the wheel parts. This will be this bleeding will be found. You can detect on the wheel parts. Last one, pumping. Pumping. So seeping or ejection of water and fines from beneath the pavement through cracks is called pumping. This is also known as mud pumping. So pumping, what is meant by pumping? Ejection of water from beneath layers of the pavement, or ejection of fines, that means sand particles, onto the pavement from beneath layers, below the pavement layers, through cracks is called pumping. So these are the distresses in the flexible pavement. That means failures occurred in the flexible pavements. So 10 types of failures will be occurred in flexible pavement. So how to design the flexible pavement? There are three types of procedures are there. So we will use some code book IRC 37 2012 based on um, different, there are three different design procedures are there: empirical design, empirical design, mechanistic empirical design, and mechanistic design. So one code book is there for this flexible pavement, IRC 37 2012, which is based on the mechanistic empirical design. Okay, so this is about flexible pavement. Now we will see what is rigid pavement. Hmm? Rigid pavement. Okay. See, this is the rigid pavement. That is nothing but which is made up of cement concrete. Cement concrete road is an example of rigid pavement. Okay, so this is the rigid pavement. So these are the joints. This is longitudinal joint and this is transfer joint. Let us see what are the types of joints in coming future slides. See. The development of any country depends on the connectivity of various places with adequate road network. Isn't it? Isn't it? Yes. So the country will be developed only with due to the connectivity of different places through with the road network. Then only development will be possible. So if you provide roads to connect different places in the country, then only country will be developed. Okay. Road constitute the most important mode of communication in areas where railways have not developed much. So wherever the railway system is not developed, in that the roads are developing. Okay, roads are developing. Okay, India has different highways: national highway, state highway, major district road, other district road, and village roads. Like this, classification of roads were done. 5 categories. Okay. What is road? Road is an open public way of vehicles and animals. Okay. It is lifetime is in between 20 to 30 years. What is pavement? Just we have studied is the flexible pavement. It is a multi-layer system which distribute the vehicle load coming onto the pavement through grain to grain distribution with a wider area. Truncated cone will be formed. The different loads, different layers will be received this wheel load. Okay, so this is the pavement structure. Okay. Uh, See, different types of roads are there: Roman roads, French roads, British roads, and nowadays modern roads. There are two types of roads: flexible roads and rigid pavements. Okay, so classification by function: airport pavements, highway and freeway pavements, parking and street pavements. Classification by function is this type of three pavements are there. Classification by structure, structural classification: rigid pavement, that means concrete pavements; flexible pavement, that means bituminous pavement; composite pavement, that means both combination of flexible and rigid. Next, gravel, that means unpaved roads. These are comes under structural classification. Basically, functional classification, structural classification. Functional classification లో మూడు, structural classification లో నాలుగు ఉంటాయి. Okay, mainly flexible and rigid pavements కింద డివైడ్ చేస్తాం. We know that. Okay, so what is the comparison? Flexible law, design principle, it is an empirical method. ఇక్కడ థియరీలో డిజైన్ చేస్తాం. ఇందులో మెటీరియల్ ఏంటంటే గ్రాన్యులర్ మెటీరియల్ ఫ్లెక్సిబుల్లో, రిజిడ్లో సిమెంట్ కాంక్రీట్. ఇందులో ఫ్లెక్సిబుల్ స్ట్రెంగ్త్ తక్కువ ఉంటుంది. ఇందులో ఫ్లెక్సిబుల్ స్ట్రెంగ్త్ distribute over the wider area of the subject soil. సో ఇక్కడ ఫ్లెక్సిబుల్లో నార్మల్ లోడింగ్ కండిషన్లో ఎలాస్టిక్ డిఫార్మేషన్ పాసిబుల్ అవుతుంది. ఇక్కడ రిజిడ్ పేవ్మెంట్లో ఈ పేవ్మెంట్ ఎలా యాక్ట్ చేస్తుందంటే ఒక బీమ్ లాగా, క్యాంటిలివర్ బీమ్ లాగా యాక్ట్ చేస్తుంది. ఓకే, ఇక్కడ ఎక్సెసివ్ లోడ్ ఉంటే ఫ్లెక్సిబుల్ పేవ్మెంట్ లోకల్గా డిప్రెస్ అవుతుంది. అదే రిజిడ్ పేవ్మెంట్లో ఎక్సెస్ లోడ్ వలన ట్రాక్స్ డెవలప్ అవుతాయి. ఓకే, స్ట్రెస్లో ఏంటంటే the flexible pavement transmits vertical and compressive stress to the lower layers. Whereas in rigid pavement, tensile stress and if temperature increases, tensile stress will be formed in the rigid pavements. Next, design practice. It is a multiple combination of multiple layers. Flexible pavement is a combination of multiple layers. Here, the rigid pavement is laid in slabs with a steel reinforcement. Okay, double bars, tie bars, etc. Next, coming to temperature criteria, no stress is produced in flexible pavement, whereas in rigid pavement, stresses will be produced. Thermal stresses will be produced. Working stresses will be produced. Next, force of friction. Next, in this parameter, less deformation in subgrade is not transferred to the upper layers. Okay, here friction force is high. Here less, here high. Next, opening to traffic. Road can be used for traffic within 24 hours. So after construction of this flexible pavement, you can leave the traffic onto the constructed pavement within 24 hours. Whereas in rigid pavement, it is not possible because it requires curing. Minimum 14 days requires, it requires minimum 14 days curing. After that only, you can open the traffic onto this rigid pavement. Next, the top layer. Rolling of the surfacing is needed. So here, rolling is required in the flexible pavement. Here, not required. Only concreting. Okay. So these are the different types of flexible and rigid pavement pictures. Okay. Distribution of reloads in rigid pavement and flexible pavement. Here, grain to grain distribution will be in flexible pavement. Here, the pavement will be act as a beam or cantilever. So in this joints will be there. I will explain in coming slides. Okay, types of concrete pavements. In this unreinforced concrete pavement, reinforced concrete pavement will be there. In unreinforced concrete pavement, that means without reinforcement, jointed and jointed doubled concrete pavements. Okay, jointed undoubled concrete pavements. Whereas coming to reinforced concrete pavement, jointed reinforced concrete pavement, continuously reinforced concrete pavement. Okay. This is called precast prestressed pavement. Precast, that means manufactured at some place and brought to the work location, and it has to be erected in the required site. This is called precast prestressed pavement. Prestressed pavement means stressing also prestressed in concrete by tensioning. Like that, the tendons will be provided in this pavement slabs, and they are placed at the required place. This is called precast. So coming to joints in rigid pavement, load transfer will be possible like this. Okay, zero load transfer efficiency. Here the pavement will be bent like this. If you provide a double bar, it will not deflected. It will not getting down. So 100% load transfer efficiency is possible by putting double bar, by placing double bars. Here, types of joints. Transverse joints, that means widthwise joints. Longitudinal joints, that means lengthwise joints. So, in the transverse joints, there are four types of joints. Widthwise: expansion, contraction, warping, construction. Expansion joints means for every some meters of length of road, we will provide this type of expansion joints for expansion contraction purpose. These two. And warping joints are provided for temperature purpose. Construction joints are provided whenever the end of the day work. At the end of the day, we have to provide these construction joints And the next day, we will continue at this same place to proceed our further work. Okay. So this is the construction joint. Okay. And longitudinal joints. These are the longitudinal joints. Okay. So what are the distresses in this rigid pavements? Cracking, joint deficiencies, surface defects, miscellaneous distresses like classified as blow up, faulting of transfer joints and cracks, and shoulder separation, patch deterioration, water bleeding, pumping. These are all the miscellaneous distresses. Okay, surface defect, etc. Like this. This is cracking, and this is transverse cracking, widthwise direction cracking, and this is corner cracking, corner breaking. Okay, and this is joint spalling, joint low spall wood bottom, separation of layers. And this is longitudinal cracking, lengthwise direction crack forming. Map cracking, we have already seen in flexible pavement. That maps will be formed on this top layer. And sealing and polished aggregate surface. Okay, these are the different types of distresses in the rigid pavement. Blow up, this is the blow up. And faulted transfer joint problem. Next, high 70 punch out. Okay. Next, water bleeding and pumping, water bleeding and mud pumping. These are the failures of different rigid pavements. So, what are the advantages? It is a long-lasting design life is 40 years. Heavy duty, heavy. It will take heavy loads. Maintenance cost 10 times cheaper than the flexible pavement. Okay, because flexible pavement consists of different layers, whereas number of layers will be less in rigid pavement. Next, the lowest life cycle cost. These are the advantages. It can be constructed over poor subgrades also. Yeah. We can use waste products like fly ash, slag, etc. in the bottom layer of this pavement. Okay. Fuel cost will be saved. Okay. Light color enhances night visibility. Okay. Coming to disadvantages, uh, on-site batch plant is essential for slip forming. Okay. Repairs take longer time. Okay, these are the mm, uh, different disadvantages. May lose non-skid surface with time. Needs may fault transverse joints. Okay, transverse joint problem కావచ్చు. It requires a frequent joint maintenance. So joint maintenance may be get problem. So it maintenance is required in this type of rigid payments. These are the disadvantages. Okay, thank you.